Welcome back, my pandemic pre-calculus fans. In this video, we're going to talk about what's called a removable discontinuity. So in the first video on domain of rational functions, I asked us to find the domain of this function. F of x is equal to x plus 3 divided by x squared minus 9. And so what we did was we set the denominator equal to 0, and we found that the domain of our function looked like this. Negative infinity to negative 3, negative 3 to positive 3, positive 3 to positive infinity in interval notation. And that's our domain. In other words, everything besides 3 and negative 3. I see a lot of students write this notation. X cannot equal negative 3, 3. I understand that. I see where you're coming from that. That makes sense to me. But notice that when we factor this denominator, we end up with an interesting situation. X plus 3 divided by x plus 3 times x minus 3. So our numerator and denominator have a factor in common. X plus 3. X plus 3. And that factor is what gave us this domain restriction that we cannot equal negative 3. So we can actually remove this factor. We can factor this out. We have a common factor. And so I'll just illustrate for you. This is the same as saying I have x plus 3 divided by x plus 3 times 1 divided by x minus 3. I'm just rewriting that. And then a number divided by itself is equivalent to 1. So now I have 1 multiplied by 1 over x minus 3. And then 1 multiplied by any number is just itself. So we can simplify this function in this way. So what we did was we removed a discontinuity. Let's write that down. That's a good one. We removed the discontinuity. At x is equal to negative 3. So we were able to take care of that. So you call something that you can deal with in this way when you can use your properties and simplify your function. You call this a removable discontinuity. So x is equal to negative 3 is a removable discontinuity. You don't want to forget it, discontinuity. You don't want to forget that it's there. And when you check for your domain, you include it, right? This is not in the domain of our function. But you can go ahead and simplify. And you would call this a removable discontinuity. I hope that's helpful for your homework. I'll see you in the next video. In the next one, I'm going to talk to you about vertical asymptotes because we got rid of one discontinuity. But what does the graph look like here? What does the graph look like when I use x is equal to positive 3? What's going to happen then? What does this graph look like? We'll talk about that in the next video.